Good morning, my YouTube viewers. It is Crystal here. I'm making another code review. Sorry, I wasn't on YouTube for the past couple of days, and the reason why is because I was sick. I had a cold, and I was really ill. I was in bed sick, although I had to go to work, which wasn't very pleasant. It's never very pleasant to go to work when you're sick, but I had to do that. But when I wasn't at work, I was laying in bed sick. So what I wanted to do is I want to do a code review for you. And what we're going to do is we're going to measure a center in R and Python. So, but when we measure a center, what we're going to do is we're going to go over some of these statistical concepts. So just in case you didn't know what they were, we're going to go over them. So the first thing we're going to do is we're going to take the code in R and then we're going to translate it into Python, but we're also going to go over some statistics, meanings. And I created the program in R in Replit, which is a free online interpreter for R and other languages, and I created the code in Python in Google Colab, which is a free online Jupyter notebook. And so the first thing we're going to do to carry out this code review is we're going to create a random number. So first thing we do in R is we set the seed up for a 1, and I guess that's just kind of like your number, and so it was a seed of 1. And data equals run if, so it's going to be 2110, so it's going to be 20 numbers. And then you see your data, so you've got your data here, which is, it's got actually 20 numbers between 1 and 10. So what we'll do is we'll come over here to Python, and in Python you can see that Python uses libraries. So we do our random.seed10 and A equals random.uniform 1 to 10, and then we print A, so you can see A down here. And then we print the length of A, which is 20, because we wanted 20 numbers. So I just wanted to make sure that we had 20 numbers. So we make random numbers of a float between 1 and 10. But in order to do that, we have to import libraries. So the libraries that we're using for this program for a measure of center is random, NumPy SNP, from statistics import mode, and Seaborn SNS. And so basically that's how you get Python to work, because Python is a general purpose language, and so it doesn't have a lot of these statistical functions in there. So if you want to use some statistical functions, you need to import a library. So we had mode is not in Python hard-coded, so we had to import mode from statistics. So we have created our random numbers, 20 random numbers from 1 to 10. So after we've created our random numbers from 1 to 10, what we want to do is we want to calculate the mean. And so if you're not sure what mean is, the arithmetic mean is the average of a data set. The mode is the most common number in a data set. The median is the middle set of numbers. So your mean is your average. So this is your formula for your arithmetic mean. And so basically what you do is you take all the numbers, you add all the numbers together, and then you divide them into the length of the list. So in this particular instance, we've got 20 numbers. So we're going to sum all the numbers, and then it's going to be divided into by 20. And that's your arithmetic mean. So in R, because R is a statistical programming language made for statisticians, all we have to do is calculate the mean. So mean equals mean data, and then we print mean, and the mean is 5.996504. So we come over here to Python, and you have to do it a little bit differently. Mean data equals np.mean data. So mean isn't hard coded into Python, so you have to use NumPy to get it. You print mean mean data, and that's going to be 5.816. And I don't know why I did this. Let's try. I don't know why I did that. I must have been really sick. Let's try it again. I must have been really sick when I was doing this. Let's see what it says. Oh, that's why it didn't work. It said no unique mode, found 20 equally common values. So that's why it did it. So it didn't have, the mode didn't work because there was no equally common value to do the mode, and that's why I printed it out like that. Now our standard deviation is working. Let's try that. That's why it's always a nice thing to do these code reviews, because when I do the code review, I pick up an error. So I pick up any mistakes that I've made. So that's why I didn't use the mode, because the mode had 20 equally common values, so you couldn't use it. So, but we did get our mean, and our mean is 5.816, and R is 5.99654, because you have to remember these are random numbers. So we don't know what the numbers are going to be. Okay, now what we're going to do is we're going to calculate the median. So your median in statistics and probability theory, the median is the value separating the higher half from the lower half of a data sample. And so basically your median is going to be the center of the data sample, and basically it's the middle. So if it's an odd number value, it's going to be the middle, and if it's an odd number data set, it's going to be right in the middle. If it's an even number data set, it's going to be the two middle numbers added together and divided by 2, and that's how you calculate the median. So we've got R. The good thing about R is you don't have to calculate it yourself. So median equals median data, print median. So our median is 6.408853. Come over here to Python. Median data equals np.median data. So you have to get median from NumPy. And then we print median data. So the median is 5944. So basically that's the center, the two centers divided by 2. So now we're going to look at mode, and this is what your mode is. The mode in statistics refers to a number in a set of numbers that appears the most often. For example, if a set of numbers contain the following digits 1, 1, 3, 5, 6, 6, 7, 7, 7, 8, the mode would be 7 as it appears the most out of all the numbers of the set. So that's your mode. Your mode is your most commonly appearing number. So we created a function to get mode, so even you can't get mode, even mode isn't hardwired into R. You have to create a function to get mode. Excuse me. A mode is a function x, so ux equals unique x, ux which dot next tabulate match brackets x comma ux. Result equals mode data. So R does things differently than Python. Python is a lot easier to work with when you're making functions. So we print the data and then we print the mode, which is 3.389578. Okay. Now we can't look at the mode in Python because there is there's no number that appears more than any other number, so we can't use mode. We get an error. And then the next thing we're going to talk about is variance. So what I'm going to do here is I don't know how to do R that much. I'm still learning. So at some point I'm going to have to take an R class, do a YouTube video on R. So we've got our mode is 3.389578. And now we're going to look at variance. In probability and theory and statistics, variance is the expectation of the standard deviation of a random variable from its population mean or sample mean. And this is the formula for variance if you want to calculate the variance yourself. But the nice thing about R is you don't have to calculate it yourself. You have a function inbuilt in R called variance. So we print the variance and it's 6.63094. Come over here to Python and you have to get variance from NumPy, and your variance is 5.810, because you have to remember that these are random numbers that have been generated. So now what we're going to do is we're going to talk about standard deviation. Standard deviation is a measure of how dispersed the data is in relation to the mean. A low standard deviation means data are clustered around the mean, and a high standard deviation indicates data are more spread out. And this is your formula for standard deviation. But the nice thing about R is there's a standard there's variance, which is hard-coded into the library, into the programming language. So std equals square root variance data. So standard deviation is the square root of the variance. It says print standard deviation, and the standard deviation is 2.575061. So we check here in Python, we check our standard deviation. And your standard deviation is 2.401. But I want to redo this, because then you can do standard deviation two ways. You can either say that the standard deviation is the square root of var data, or you can calculate standard deviation yourself, because there is a standard deviation function in NumPy. So let's just try this again. So 2.4010. So we've got the standard deviation there. So it's either, you can do it one of two ways. You can either say it's the square root of var data, or you can use the standard deviation function that's coded into NumPy. And then so we've completed all of our measure of center measurements. And so what we're going to do is we're going to make a histogram. And the thing about R is in Replit is a histogram is made in a PDF file. So you have to call the PDF file up. So this is our histogram in R. And then we look at our histogram in Python, and you can see the histogram looks a little bit different. And the reason why the histogram looks a little bit different is because in R they've set up bins and everything like that. But what we can try to do is this. See what happens. Just see what happens. See if it'll accept it. Okay. So it's the same. The histogram is the same in R as it is the first time as it was the second time. So I think what that means is in R, the histogram has different parameters than it does in Python. But this is your histogram in Python. But let's say, so I think that's about it. But if you want to do another little experiment, we'll say 200. And let's try another one. Let's say 2,000. Well, it's not really working out how I wanted it to work out, because I wanted it, because it's supposed to be like the more samples you have, the more it looks like a bell-shaped curve, but this isn't working out as a bell-shaped curve, not at all. So that didn't work. I just wanted to see, because like the more samples you have, the more it resembles a bell-shaped curve, which it doesn't resemble a bell-shaped curve here, but it was a good experiment anyway. So that concludes our code review on the center of measure. And so you can practice it yourself if you want to. And I'm still learning R. So I've been working with Python for about more than 2 years, but I've just now started working with R. And the reason why is because a data scientist needs to know both R and Python. And so generally they use R for study and research, but they use Python for work. So, and I think that anyway, that's just the way it is, the way it's done. But if you're going to be a data scientist, you need to know both R and Python. So that's why we're doing this code review of both R and Python. So I'm going to conclude this video because I've talked for more than 20 minutes. If you like my video, please like, subscribe, and share. And I would like to thank all of my subscribers for supporting my channel. Thank you very much for watching my video. I look forward to making more videos for you in the future.